Hello, this is Satbir. The topic of the discussion in this video is applied optimization, which are also known as word problems. So before we start word problems, these are the five things which we will basically give a more focus on or try to write these five steps for each optimization problem. The very first step is should read the problem very carefully and draw a diagram if applicable and fix some annotation. In the second step, you would like to attempt to find the objective function and what are the constraints. So we will write down the objective function and constraints in the step number 2. And in step number 3, you should also identify what are the constant and variable and what are the domain for the variables. And my suggestion number 4 is use the constraint to rewrite the objective function in terms of a single variable. So once we have a single variable function, we will use the calculus to find the absolute max and absolute minima of the objective function on the appropriate domain. So these are the more or five steps which we will try to do in each problem. And also, please, there are some videos on minimum or maximum, absolute min or absolute max. Please watch those before you watch this video. So let's start with our first example. In this example, let's first to read the problem and try to understand what is the objective and what are the constraints. A piece of wire 10 centimeter long is bent into a rectangle. So I can find some keyword. The keyword is a rectangle. So I will draw that diagram. So I have a rectangle. And that rectangle is bent. So that wire is a bent into a rectangle. What dimension produce the rectangle with a maximum area? So our objective will be to find the maximum area of this rectangles. So that's our objective is. The first step is we will fix some notation. What will be our notation is like we will denote x the length and y the width of the rectangle. So let x and y be the side length. So once we have fixed the notations, now we can write the objective function. What is our objective in this problem? So keyword for the objective function is to look in the problem is you find the word max or min. So here I can see that the objective is to maximize the area. So our objective is area. And we know that the area of a function, area of a rectangle whose length is x and width is y, is x times y. And now in the next step, we will find what are the constraints. Constraints are the condition, or most of the time the constant which are given. A piece of wire 10 centimeter long. So it means when you bend that piece of wire into a rectangle, the parameter of that rectangle cannot be more than 10 centimeter. So it means parameter x plus 2y should not be more than 10 centimeter. So once you write the constraints, you always try to simplify the constraint or find the constraint in one variable and take the another variable on the other side. So if I simplify the constraint, it will be 5 minus x. So this is my first equation, which is a y in term of x. Now I will use this constraint to rewrite my objective function. So in this step, you rewrite objective function. So now my objective function will be depend on one variable, area x. So I'm gonna replace y by 5 minus x and simplify this equation. 5x minus x squared. So now I have a function which is the area in term of only length 5x minus x squared, and I would like to find what is the domain of this function. So as you can see, x can minimum of x I can choose is 0, and the maximum x I can choose is 5 unit, because I cannot, because the piece of wire is 10 centimeter long. If I have 5 unit here and the 5 unit here, then y will be 0. So that's the max I can go, because I cannot go more than 5 unit, because then I wouldn't have anything on the other side. So this is the maximum possibility is. Now we will, this is a math problem, which is the absolute max and absolute min problem. So I will take the derivative of this function a prime of x and find the critical value, which is a 5 minus 2x. If you set the derivative is equal to 0, this will give you x is equal to 5 half. So this is the only critical value you have, which is inside the interval. So you will draw the table because we are on the closed interval problem. So we will draw the table instead of the line test. So here will be x end point is 0 and 5, and my critical value is a 5 half. And I will calculate the y value or the area. If I plug 0, I will get 0. If I plug 5 half, I get 6.25. I will plug in that 5 half into here. And if I plug 5, I will get to 0, because 25 minus 25 is 0. So as I can see, this is my absolute max, because my objective is to find the maximum area. So this is the maximum, which occur at x is equal to 5 half. If you plug x is equal to 5 half into y, if you plug that into y, so y will be also 5 minus 5 half, which is again also 5 half. So y is also 5 half. So this is the dimension of my rectangle. So if I have the length and width of my rectangle 5 half, and y is equal to 5 half, that gives me the maximum area, which will be 25 over 4. Okay, let's overview this problem again. I choose my length and width of my rectangle is x and y. I fix my notation. I choose my objective function, the area that's in the problem was given, and then my constraint I write down and simplify the constraint. Y is equal to 5 minus x. And then I write down the objective function, and I calculate the derivative of objective function and find the critical value, and then draw the tables and find the absolute max. So this is the solutions where x and y both are 5 half. That is the rectangle is actually a square. Let's move to the next problem. This problem is find the two non-negative real number. So here you can see that maybe a diagram is not possible to draw in this problem, but we will see that without drawing the diagram, we can extract all the information from this problem. So even the notation is already fixed in this problem. The x and y are given as a sum of two functions. So I can start writing down the objective function. So what is my objective function? So objective function again will be, the keyword will be the largest or the maximum or the minimum. So as you can say, product is a largest possible. So my objective function will be the product of two number, which is x and y are two numbers. So that's my objective. So let's see what are the constraints. two non-negative real number x and y such that their sum is the constraint x plus y, it is 120, and both are positive number. So I can simplify my constraint. It's going to be 120 minus x. So this is my first equation of y, and then I rewrite my objective function. So if I rewrite my objective function, is going to be only a function of x, and this is going to be x times 120 minus x. You can simplify a little bit more. So this will be a p of x is equal to 120x minus x squared. And now we need to find what is the domain of my objective function. As you can see that x is given is bigger than 1. So x is starting from 0. And since x and plus y is 120, I can choose my y 0 and then x will be 120. So my objective function, the domain of the objective functions will be 100 to 20. That the x max can choose if I choose one number 0. But if choose one number 1 and then another number has to be less than 190 and so. So this is my objective function and this is my interval. So this is a closed interval problem. We will calculate the derivative of this function. So it's going to be 120 minus 2x. We will, if we set the derivative is equal to 0, 120 minus 2x is equal to 0, then my critical value will be 60. Critical value. So we have the critical value, and then we will draw the table 0, 120, and 60. So then the value will be plugged into the objective function. If I plug 0, everything is 0. If I plug 60, then I will get 3600. And if I plug 120, that will be 0. So this is your maximum. So x is equal to 60 is your maximum value. If you plug x is equal to 60 back into this equation, 120 minus x. If x is a 60, so y is also 60. So your both number should be 60 and 60 in order to get the maximum product when their sum is 120. So you can see that 60 plus 60, 120, their product will be 3600. That's max you can go. So we see that when we find the two largest number on a two non-negative the number whose product is maximum, our objective function is x 120 minus x on the domain 0 to 120. What if I lift the restriction that the two number can, that what happens the problem if we remove the qualification that the number be non-negative? If I remove that restrictions, what will happen to the problem? So you can see that in that situation, so your domain is going to be no longer from 0 to 120. It can go minus infinity to infinity, and we not be longer to use the closed interval method. In these situations, we will use the line test. And so if we do the line test, so we already saw that the 60 was the critical value, and we have minus infinity to infinity. If I plug a number which is a less than 60, then I will get basically this is a and the what is the derivative of this function p prime of x? It was 120 minus 2x. So if I plug a number which is less than 60, let's suppose 30, and then that side will be positive. And if I take a number which is bigger than 60, that side will be negative. So function is increasing to decreasing. So this is a absolute max. So in that situation, you have to use the line test to figure out the problem. And we will have the same basically conclusion that 60, is the absolute maximum point. But however, we will not be able to use the close interval if there is a one restriction has been left, but we'll still be able to solve that problem, this problem. Here I have one quiz problems for you to practice. Please pause the video for 1 and 2 minutes and leave your answer in the link above. There is another problem which is very similar to the sum of two non-negative numbers is 16, that product problem. Pause the video again for 1 and 2 minutes, practice this problem, and leave your if you have any questions in the comment section below, and leave your answer in the link above. My problem number 3 is, what is the maximum area of a rectangle inscribed in a right triangle with a side length 3 and 4? The side of the rectangles are parallel to the leg of the triangle. So after reading the problems, I should be able to draw a diagram. So one thing we are given is a triangle. And there is a rectangle inside the triangle. So let's draw that too. So this is the situation. So, and we can also draw the axis here. Let's suppose this is the x-axis, y-axis, and this is the x-axis. Yeah. So what are the maximum area of a rectangle? So our objective is to maximize this area. Inscribed in a right triangle with a side length 3 and 4. So this is a side length. Let's suppose this is a 3. This is a 4 unit. This is a given. These are the constant which are given. The side of the rectangles are parallel to the length of the side. That's also given. And there is an also keyword inscribe. It means that this edge is on this line. So this means inscribed. So first I will define the variable, or also is called and fix the notation. So since this point should be on the side of hypotenuse of the right hand triangle, I will choose that this point is x comma y. What I mean is this length is x unit and that length is a y unit. So let x comma y be the one edge of this problem, be the point, be the edge of be the one edge of our rectangle. So that's my notation. So if these are my notation, what is my objective? My objective is again where you find the maximum area. So this is my keyword, maximum area. So my objective is the area of this rectangle. So if this is a x and this is a 3 unit, so this from here to here, this will be 3 minus x. If this is a total, this is a y unit, because this is a y component, so this is a y unit. So my area will be 3 minus x times y. That will be the area of my objective function. What are the constraints? So the constraint, since this point is on that line, so what is the equation of that line? Y is equal to slope. Slope will be, this is a 3 unit. If you run 3 units, you rise 4, rise over run x. That is the slope of this line. So that is my constraint, which is already simplified. So I will rewrite my objective function. My objective function will be now 3 minus x times 4/3 x. So I can simplify my objective function before I calculate the derivative. This 3 multiply 4/3 over x is going to be a 4x minus 4 over 3x square. And now the question is, what will be the domain of this function? So x can be placed here, or anything from 0 to 3. So it will start from 0 and 3. So maxes can go 3, because x is the one edge of exponent of the one edge of the triangle. So it cannot go, at least it can go here, which is a 3 unit. So there will be no rectangles inside though, but that's the max it can go. If I calculate the derivative of this function, is going to be a 4 minus 8 over 3x. And if when we set that equal to 0, 4 minus 8 over 3x is equal to 0, it will gives me x is equal to 12. So x is equal to, if I multiply 4, then I will take the 4 on the other side and then divide over 3 over 8. So that will cancel to 2, it will be 3/2. So my x is a 3/2. So now I will draw the table. It's with 0, this is a 3/2, and that is a 3. And then I will calculate my area. That's going to be 0. This is a 0. If I plug 3/2 into my objective function, so let's see what I can get if I plug 3/2 into here. So I will do this calculation. So 4 times 3/2 is 12. And if I plug 3/2 here, is going to be a 4 over 3. It's going to be a 9 over 4. So that's cancelled to 3. That's cancelled. So it's going to be a 12 minus 3, which is 9. So this is a 9, which is a maximum. So x is equal to 3/2. And what will be our y? If I plug y 3/2 here, that will be our 4. So that will be the dimension of our rectangles to get the maximum area. Our next example is example number 4. A box with a square base and open top must have a volume of 32,000 centimeter cube. Find the dimension of the box that minimize the amount of material used. So there are a few keywords. One keyword is, you can see the box. So we have to draw a box. So we have this box, which has a which has a square base. It means this base is a square. If I choose this x, this has to be x. And let's choose y is the height of the box. So I basically fix my notation. X is the length, x is the width, and y is the height of my box. It has a volume 3200, and that's something as the constant. Find the dimension of the box. So minimize. So this is again the keyword, minimize the amount of material used. So minimize the amount of material used. So what it makes it to get basically to make the box, we have to minimize that. So in order to make a box, so basically the material used is basically the surface area of the box. So our objective function is surface area. That's our objective. So what will be the surface area? So the area of this side is x square, because it's a square box. So that is the x square. Area of this side is xy, so, but there are 4 of them, so 4 times x y. And the open top, so top is open, so there is nothing in the open. So this is the objective function, x square plus 4x. What are the constraint? The constraint are the material used, that a constant is mostly the constraint, which is the material used, which is a volume of the box. So volume is x times y, so the x square y is equal to 32,000 centimeter cube. That is the material which is used to build that box. So now I will simplify the constraint and then rewrite my objective function. So I'm going to rewrite objective function. So if we rewrite our objective function, it will be only depend on one variable x. It's going to be x squared plus 4x times 32,000 divided by x squared. And if we simplify this objective function, what we are going to get is x squared and 4 times 32, which is I guess 128 plus 128,000 divided by a 1x, cancel out that, so 1 divided by 1x. Now also try to find what is the domain of this function. So as we can see that x can be x and y. First of all, x can be 0 is the, because you cannot take the negative length, but all you need is here this constraint x squared y is equal to 30. So if x is a 0, y could be anything, or if y is 0, x, so if y is a really small number, and if you divide the really small number, x is a very large number. So your domain can go to 0 to infinity for this function, because 0 can be included sometime. Because you see that from here in this equation, if you choose y is here, y, if you choose y is really small and you divide over, x could be really large. So your y value, the end point of your x value can be really large. Okay, so that will tell me that we cannot use anymore the close interval method. So this time I will use the line test, which is basically open interval method is. So I need to find the critical value. So I will find the derivative function, which is going to be a 2x minus 128,000 divided by x square. If I substitute the derivative is equal to 0, I will get my x. So you can pause the video for a minute and do the simplification. It will basically simplify to 2x cubed minus 128,000 divided by x square. So if you put the top and bottom is equal to 0, the top will give you x is equal to 40. So that's your critical value. The only critical value you get from the top is that. Bottom will give you x is equal to 0 critical value, but that's only the end point point of the interval. So now if I do the line test, if I choose 40 here, if I choose a point on the left and plug into the derivative, I will get a negative sign. And if I choose a point from the right side of 40, which is a 50, and plug into my derivative, I get a positive sign. So negative to positive, this is a minimum value. So function was decreasing here, then function started increasing. So this is a minimum. So x is equal to 40 is your minima. If you plug x is equal to 40 into your y value, which is here, you get y is equal to, what you will get, y is equal to 32,000 divided by 40 square, which is basically 60. So you get 20. So your dimension of this this box is 40 times 40 times 20. So this is your dimension of the box is. Our next example is example number 5 here. Let's read this example together. A landscape architect wishes to enclose a rectangular garden of area 100 meter square. On one side will be a brick wall costing $9 per linear meter, and on the other three side will be a metal fence costing $30 per linear meter. What is the dimension? What dimension minimize the total cost? So let's first pick up some keywords. So keyword is a rectangle. So we will draw a rectangle. So one side will be a brick wall. So let's suppose this side is a brick wall. And one side of the rectangle is a brick wall, which is a cost $90 per meter or per linear meter. On the other three sides, so these three sides are like a fence. So my red is a fence. So here is a fence, here is a fence. So I will fix some notation. First I say let's my x is my length of this rectangle and y is the width. So these are my, what is my objective function? The objective function is again minimize the total cost. Cost is the objective. So let's see that what will be the cost to build the each side of this triangle. So since this is the length of this this side is a x unit, and the fence is on this side, which is called a 30 meter. So it will be 30x will be the cost of this side to build, and 30 will be the cost of this side to build. So 30y will be, because this is the y is the, and 30y will be to build that cost. But here, which is the x length, x unit, so that's the 90x is the cost to build that length. So let's see what is the total cost. So C is the total cost. Is going to be a 30x plus 90x plus 30 plus 30y, 30y, and 30y. If I simplify this function, is going to be 120x plus 60y. That's my objective function, which I have to minimize. Now let's find what the constraints are. The constraint is like here area, which is a constant of the also the problem, the area. What is the area? If this is a x, this is a y. So x, y, the area is a 1,000 meter square. 1,000 meter square. So I will simplify my constraint, which is going to be 1,000 divided by x, and I will rewrite my objective function. So C is going to be only a variable of X is going to 120X plus 60 times 1000 divided by X. If I rewrite my objective function, C of X is going to be 120X plus 60,000 divided by X. The domain of this function again can be starting from 0 to infinity because the area has no limit. So you can choose one side really small and other side really large and still can get the area 1000. So let's suppose you take 1 million one side and another million, choose in a way that when you multiply these two numbers, they end up 1000. So that's our domain of the function. So now I will calculate the derivative of this function, which is a C prime of X 120 minus 60,000 over X square, which will be simplified to 120 X square minus 60,000 over X. So what will be my critical value in this situation if I solve that problem and find my critical value? So critical value will be X is equal to so critical value will be X is equal to 5, X square is equal to 500. Therefore, X is equal to square root of 5. So this is my critical value. If I do the line test here somewhere, let me erase some portion of the problem. So I'm going to erase this derivative here. So if I do the line test on this number, which is the square root, which is a 10 square root of 5. If I choose a number from here and plug into the derivative of my objective, is going to give me a negative sign here and positive here. So negative and positive, so this is a minimum value. So X is equal to, so X is equal to 10 square root of 5. And then if you plug that to get the Y value, that will be 20 square root of 5. So this is the dimension of the box is a 20 square root of 5 times 20 square root of 5, 10 square root of 5 times 20 square root of 5. So this will be the dimension of our box in that situation, in this problem. So here is another example number 6. In this example, so let's see what is our objective and constraint of the problem by first reading the problem. So we have a poster of area 6,000 centimeters square, has a blank margin of width 10 centimeter on top and the bottom and 6 centimeter on the side. Find the dimension of the poster that maximize the printing area. So this is the diagram of our problems. Look like we have this poster and it has some printing area. So it's only, let's suppose this is the printing area. And there are some margin on the top and bottom. So top has a margin 10 centimeter. So like this is a 10 centimeter of top and bottom. So 10 centimeter is on bottom also. And side, this is a 6 centimeter and that's a 6 centimeter. Okay. So that is the diagram of our word problem. So let's define fixed sum notation. I can fix that X is the length and Y is the width of my poster. Then if that is the case, then this will be X minus 20 will be the width, the length, and because, sorry, 12, because 6, we took the 6 unit from each side, and the length will be y minus 20 of the printing area. So this will be the situation of the printing area. Is the length of the printing area is x minus 12, the width is y minus 20. The width is y minus 20. We have fixed the notation, so let's why not we write down the objective. The keyword for the objective function is a printing area. So my printing area is this time that. So x minus 20, x minus 12 and y minus 20. That's my objective function. What is the constraint? Constraint is the poster area can only be 6,000. So x and y is the area of the poster. It can only be 6,000. Therefore, y is equal to 6,000 divided by x, and I will rewrite my objective function. If I rewrite my objective function, it will be only a variable of 1x, so x minus 12, and that will be y, which is a 6,000 divided by x minus 20. You can simplify this one. But I'm leaving right now 6,000. I'm missing 1 0, which is important. And the domain of the function is again can be a 0. The minimum length you can choose is a 0. It's going to be just for the minimum. Okay, no, sorry, you can't even choose a minimum 0. So minimum x you can choose because this should be you have for some printing area. The minimum x you can choose is a 12. Because if you choose x, this is the 0 length, and the minimum, once you choose, let's suppose you choose 12, then what you can choose y, the y you can choose 300. This direction, because if we choose, then the y will be the everything, and if you plug that y is here, you will get 300. So that's the maximum x can be. So that's the maximum x. This is your interval. So you cannot choose more than 300 because otherwise you will not have any width of that printing area. So if you choose that 300, the y will be really small. Y is almost to 0. So as you can see that y cannot be less than 20. So minimum value of y is a 20. If you plug 20 is equal to 6,000 and then x, then basically your x will be 3,300. So this is how you find the maximum value of x, because the minimum value of y can be 20, because if you plug less than 20 here, this width will be negative, which is not possible. Okay, this is our objective functions. What we will do is next we will calculate the derivative of this function. So I will let you calculate the derivative. Please pause the video for 1 and 2 minutes and calculate the derivative. I have already calculated the derivative and simplified it. So my simplified derivative is a 20 x minus 60 x plus 60 divided by x square. If I set the derivative is equal to 0, my critical value will be 60 minus 60 and 0. These are the critical value. Since this is a closed interval problem, the domain started from 12 and go 300. The only critical value is 60, which is inside. These two critical value does not belong to the interval, so I will ignore them. So if I compute my printing area, so at 12 it will be a 0, at 300 it will be a 0 because there will be no width almost and not length. And this is a 38 or 40, and this gives you the maximum. So your X is 60, and when you plug X is equal to 60 here, your Y will be 100. So your dimension is 60 times 100. So here's sort of basically the overview of the problem. You can see that these are this step of the problem which are written here, which written for. Here I have one more quiz problem for you. Please stop this video for 1 and 2 minutes and try to work on this problem and see that if you have mastered the concept. And once you finish this problem, you can leave also answer in the link above. Leave your comment in the comment section below if you have any. These are all these examples I have in this video. Thank you for watching this video, and subscribe the channel and hit the bell button so you can get my next video. Bye for now. Thank you.